All right, so I want to give you a quick refresher before the exam tomorrow. The very first thing is that let's look at an equation like y equals 3x plus 0. Now we know that is really y equals 3 over 1x plus 0. The big parts here that are really important, and the other way I could write this is y equals 3x. They mean exactly the same thing. But the big thing to realize about direct variation is it has to have two things. The very first thing is it has to have a k, or a constant. Remember, the k is, it sounds strange because it's k, but constant starts with a c. In any case, it just means that it has a slope. So if I have like this right here, y equals 3x, that has a slope, a constant slope. The other criteria, there has to be a total of two of them. The second one is that it passes through 0, 0. So on my graph, when I would graph this out, it would pass through this point of origin. That is the really important part of direct variation as well, because it makes it proportional. So let's just give an example of what this looks like. First of all, these right here are examples of direct variation. And again, the reason why is that it has a slope, either 3 over 1 or 3, meaning the same thing. And there's no starting point. And if there's no starting point, that means that it will go through the origin, point 0, 0. Now let's just show what would happen here if I actually fill this out. I think it's important to see it. So if I plug in an x and a y chart, and I put in a 0 here, and 3 times 0 is 0, plus 0 is 0. If I put in a 1, 1 times 3 is 3, 3 plus 0 is 3. If I plug in a 2, so I'll plug in a 2. So 3 times 2 is 6, and 6 plus 0 is 6. So I'll have 2 and 6. If I plugged in a 3, 3 times 3 is 9. 9 plus 0 is 9, right? The whole point is, if I look here at my different numbers and I want to figure out my slope, remember it's the change in y over the change in x, right? And that's why I have 3 over 1 in every case. But you could also look to see that these are proportional. When the x is 1, the y is 3. When the x is 2, the y is 6. When the x is 3, the y is 9. So all that I'm doing is I'm taking this first one here, and I can actually multiply the x term by 2. And if I multiply the x by 2, 1 times 2 is 2. And I can take the y term times 2. So 3 times 2 is 6. If I look at, and I multiply instead by 3. So 1 times 3 is 3. And 3 times 3 is 9. Notice that if I apply a scale factor to this ordered pair, again, my ordered pair was 1, 3. And if I apply a scale factor, let's just say times 4, right? So that means that I multiply the x term by 4, I'll get 4. The y term by 4, I'll get 12. When I look at this, and if I have a 4, and if I go by 3 every time, 9 plus 3 is in fact 12. This is what I mean by proportional. It goes up by the same amount every time, right? And I have a scale factor. I could take this thing where x is 1 and multiply it by a scale factor, where I got my 4 here, and my y will go up by the same amount, 3 times 4 as well. Let's give one more example of this so you can give it a try. Here is my example. I'll say y, oops, that's a little big, huh? I'll say y equals 5x plus 2. Now if I look here, I want to figure out if this is direct variation, and I want you to think about this for a second. It has to have two things, right? So pause the video and figure out if it has the two things you're looking for. All right, so hopefully the two things you were looking for was, one, a constant, right? Y equals that k times x, that constant, or a slope. And if I look here, it does in fact have a slope. So that part is good, check. But remember, it has to go through 0, 0, meaning my starting point has to be 0 or nothing there, right? Well, this one has a 2. Since it has a 2 here, it is not direct variation. No check. So this one will not work. And I want to show you what this one looks like as opposed to the last one that I showed you. So if I go here and I go x and y, and I plug in a 0 and 2, because I plug in 0, 5 times 0 is 0, plus 2 is 2. So that's my y term. If I plug in a 1, 1 times 5 is 5, and then 5 plus 2 is 7. If I plug in a 2 for my x, 2 times 5 is 10, plus 2 is 12. If I plug in a 3, 3 times 5 is 15 plus 2 is 17. Remember before I said if it's proportional, if I take my unit, so when it's 1, so when x is 1, I'll put down 1 and 7. And let's do a scale factor. Let's say times 3. So I'm going to multiply this times 3, and I'll get 3. And I'll multiply the 7 by 3, and I'll get 21. Well, if I look here, this ordered pair was not 321, it was 317. And the reason why it didn't work is because of this plus 2. This messes everything up. So look, I'm going to do another one here. And I'll just put down y equals 4x plus 0. I'll do my xy. I'll do 0, 1, 2, 3. All right, if I plug in my 1 or my 0, I get 0. If I plug in a 1, I'll get 4 plus 0 is 4. 2 times 4 is 8, plus 0 is still 8. And then 3 times 4 is 12, plus 0 is 12. And if I look here and I take my unit rate, right, by 4, 1. If I take that and I apply it by a scale factor, let's do it by the 3. So times 3. Well, 1 times 3 is 3. And 4 times 3 is 12. It works. And the reason why it works is because there's no starting point. So that's the important thing. The two things, again, the y equals kx, which means the constant slope, and it has no starting point. So another example that you may see is something like this right here, where I'll have y plus x equals 1. And I'll say I want to figure out if this is direct variation. Well, in order to figure out direct variation, remember it's got to be y equals kx. So I have to move the x term over, right? So I have to draw my line, subtract 1 from both sides, and I'll have y equals negative x plus 1. Well, if I look at this, I have my constant. I have a slope. It's perfect. So that's a check. But I also have something on the starting point, right? It starts at 1. So this does not work. It will not be direct variation. The third thing I want to show you is something like this. And I'll say y over 5 equals 2 over x. And if I have something like this, I want to set this up again where I have y equals, so I have to clear out this 5 down here. Well, the way that I do that is I would multiply this top one by 5 over 1, and multiply this by 5 over 1. And now I will have my y equals 10 over x plus 0. Well, let's take a look at this for a second. If I have this, if I have 10 over x, is that going to be y equals kx? And it's not, because whatever I have for this 10, I'm then dividing this by x. That's not what's going on up here. This is multiplication that's going on. And it will not work. And you could prove it. So I can go through, and I can do x and y. And for all of these, you could just prove it and see if it works, like how I've showed you the last couple times. So I could plug in like a 1. Well, 10 divided by 1 is 10. If I plug in a 2, 10 divided by 2 is 5. If I plug in 3, it will not work out perfectly. It'll be like a 3.33. So we'll just do that 3 and 3.3 repeated. Again, so if I take this one where I have the 1, so I have my 1, 10, and I apply my scale factor, so let's say times 3, well then this should be, if it's proportional, it should be 3 and 30. It isn't. It's this. So that right there is proof that it is not direct variation. In fact, this actually gets smaller. This is called indirect variation, which we'll talk about in a future class. So hopefully that's helpful to go through those different examples. The big thing for the test is know how to find out if things are proportional or not by solving for x. So going through, and if I have like 3 over 4 and x over 10, to do the whole thing where you do cross multiply, and I have 4x equals 30, and in this case x equals, and I have to go through, 30 divided by 4 is like 7.5, I think. So I'll say x is 7.5. Knowing how to do that cross multiplication, being able to set things up. So for instance, if I said that I have 5 wins and 13 losses How do I set that up as a fraction of wins to losses? Well, as a fraction of wins to losses, it'd be like 5 over 13. If I said wins to total, think about how that's different. Wins to total, that would be 5 over, what is 5 plus 13? Oh, 18. These numbers are different because this one says wins to total. This one says wins to losses. So just paying attention to what things say, multiplying or solving for x, and understanding that direct variation has to not only have y equals kx, or that constant, but also that it must not have a starting point. It must be plus 0, or have nothing there for the starting point.